Great. Hi, everyone. Welcome to the LimePoint and Kubecost webinar. My name is Morgan Davies. I'm the Senior Partner Manager at Kubecost, and I'm joined by my colleague, Mike Riggs, Solution Engineer, and Goran Stankovski, the founder and CEO of LimePoint. Today's discussion is going to be focused on enterprise Kubernetes cost optimization. We all know that Kubernetes provides many benefits for organizations, including improved scalability, and simplified deployment and management of containerized applications. However, in the context of enterprise organizations, Kubernetes infrastructure and platforms can present several operational challenges, hence the creation of Kubecost. So if you're not familiar with us, Kubecost is a tool that helps organizations monitor, analyze, and optimize their Kubernetes usage in order to reduce costs without sacrificing performance. Our platform provides insights into resource utilization, application health and performance, and provides cost projections and optimization recommendations based on your usage patterns. So as mentioned, we're really proud to be aligned with LimePoint, our reseller partner in Australia. And Goran, before we start the demo, perhaps you would like to discuss some of the benefits of Kubernetes in the enterprise, and why you partnered with us. So with that, I'll hand it over to you, Goran.
Thanks, Morgan. And yeah, certainly really excited to present this webinar, particularly with, emerging technologies like Kubernetes. I'll just get you, Dee, to just go on to the next slide, please. Yeah, so I guess what we're seeing in enterprise, certainly lots of benefits. Kubernetes as a platform itself, the scalability, availability benefits that it can deliver, having application portability, the ability to move them cross-platform, and also increase application density on top of the hosting platforms you provide. And, certainly there's lots of benefits there from a cost-saving standpoint. But on the flip side of that, what we're seeing is with increased adoption of Kubernetes platforms in enterprises, in order for that to occur, we need to bring together people, process, and the technology. And often what is the case is, resulting in organizational challenges in doing so. Next slide, please. So Jeremy Corbett is a comedian. He's got this little bit that he does, which is he talks about the immutable law of the universe being this fun, unfun balance. Wherever you have lots of fun and undertake lots of fun activities, there is a corresponding unfun element to it that needs to balance it out. Otherwise, it'll disturb the equilibrium of the universe or whatever. But I won't do it justice by going through his bit. But in terms of how that relates to a Kubernetes platform in enterprise, I think there's lots of parallels that can be drawn there. When we're talking about, rapidly deploying containerized applications, Kubernetes gives you the ability to be able to do that. That's absolutely super fun as an activity. You can get lots of benefit in being able to do that really quickly. Similarly, again, one of the benefits of Kubernetes is the ability to sort of dynamically scale up and down the platform to adjust to your sort of changing workloads. Scaling out your application with a pod autoscaler is fantastic. You can scale up your application so it can respond to workloads dynamically. Super fun. Scaling out your cluster with a cluster autoscaler. So as your capacity approaches its limits, it can automatically scale out and spin up new capacity, from your underlying infrastructure provider. Also super fun. But then on the flip side of that fun, what happens when we no longer need that capacity? Scaling down applications and associated pods, certainly can be done with a pod autoscaler, but that results in some challenges. We start getting fragmentation. If we've scaled out our nodes to X amount within, during an autoscale function, scaling it back down, scaling applications back down, you start getting pods being fragmented across these nodes. So now you've got, lower density of your pods across all your nodes. So now you need to look to scale down your nodes as well. So how do you do that when you've got pods that are fragmented across all the nodes? So you need to start shifting them and moving them off nodes before you can sort of scale back the nodes. So now it starts bringing some challenges associated with that. It's a little bit unfun. Next slide, please. Similarly, from a Kubernetes in the enterprise standpoint, delivering a shared platform across the entire enterprise delivers enormous benefits. You can deploy your applications across multiple clouds and on-premise, so give you that portability aspect. Absolutely, really, fantastic technology, and the ability to be able to deliver that to an organizations, can deliver phenomenal benefits. But on the flip side of that, who's going to pay for that? How do you recover these costs, particularly in a shared environment? You've got large organizations that have, many different applications, potentially from many different departments. How do you recover the cost of that, particularly across a shared platform consumption? How do you divide up the usage of that to ensure that people are paying their fair share? That's an unfun conversation to have, and often something that's put in the too hard basket in enterprise. Next slide, please. So why did we end up partnering with Kubecost? So we've been seeing these challenges in the market, and we see Kubecost as a leading provider of technology in this area that can certainly help make this unfun activity fun again. How do you sort of recover, cost recovery, and how do you accurately reflect that cost recovery mechanism, be able to demonstrate to organizations, usage of the platform, by the associated, consumers of it? How do you optimize capacity and help plan accurately in terms of capacity consumption? If you see you've deployed X amount of nodes in your Kubernetes clusters, but you find that the utilization of those clusters are actually quite low, you can probably pare back quite a bit of that infrastructure, reduce your costs, and deliver cost benefit as well as capability to be able to scale up as and when you need it. So it just gives you that observability across all your Kubernetes clusters, regardless of where they're deployed, whether you deploy them in your cloud or whether you deploy them in an on-premise environment. It gives you that ability to be able to accurately, manage your portfolio. And so what I'd like to do now is, not spend too much more time on talking about these things, but rather show you and I'd like to hand you over to Mike Riggs from Kubecost, who's going to take us through a full demo of the platform, so you can see how you can leverage the platform to deliver value to the organization.
Very good. Thanks, Goran. I appreciate it. Let me see here. Let me share my screen right quick. Dee, do you want to stop sharing there for a second so we can throw this out there? All right. So I'm going to start with a quick little architectural overview, just so I think it helps everyone understand, a little bit of kind of what we're talking about, how Kubecost is built. I think it helps to kind of understand a little bit of the bits and pieces in the background. So at its core, Kubecost is a workload that runs within your clusters, and we're going to grab metrics from a couple different places. We're going to use Prometheus. We're going to pull kubestate metrics. We're going to pull data from Node Exporter. We're going to pull some information from Container Advisor. And this is going to give us some insight into the workloads that are running in the clusters, resources that are being consumed, how long those workloads have been running. It just gives us a nice overall picture of the workloads that are running and resources being consumed in your cluster. We're also going to ingest billing data from your cloud. So what this allows us to do is we're going to simultaneously pull in public billing data, or their published billing data, and then we're going to bring in your billing data, and we can do some reconciliation between those two things. So if you have, for example, things like savings plans, discounts, we'll be able to give you those costs accurately and reflect those discounts in the Kubecost UI. So this is the core architecture. This is kind of the basis of it. There are effectively two kind of different Kubecost versions. There is a free version, which is what we're looking at here. It's fairly straightforward. The enterprise version expands on that just a little bit. And then we introduce this idea of primary and secondary clusters. So in my diagram here, my primary is cluster A. My secondaries are going to be clusters B and C. Cluster A is going to work pretty much like the diagram we just looked at, in that it's going to provide the UI, it's going to provide the API access, it's going to do the billing data ingest. The difference here then is that all of my clusters are going to write their Prometheus data to a centralized object store, and then using the UI of the primary, we can query that object store, and what that gives you is visibility across all of your environments in a single user interface. So that's kind of a little bit about the architecture, the kind of two different flavors. Let's take a look at what that looks like in practice. And what I would ask is that, I'd certainly like to entertain questions, make sure that everybody gets out of this what they'd like to. So as we go through this, if you just want to post questions in the chat, we're going to leave a few minutes at the end to answer those. So don't be shy. Feel free to ask questions, post it in the chat as we go along. This first page that we're looking at, this is my landing page. You can think of this as sort of a dashboard or an overview page. We have some reports up here at the top that we can drill down into. But more importantly, or more interestingly, these are my clusters. So we've got this ability to look at the data for all of these clusters, no matter where they are. And in my environment, I've got clusters in AWS, I've got clusters in Azure, I've got clusters in Google Cloud. And the nice thing here, again, is using that enterprise architecture, I can see all of my data for all of these clusters in one place. The rest of the stuff that's on this front page here is going to be some trending information and some kind of overall efficiency figures. We've got down here at the bottom, this is what we call cloud costs. And so these are going to be things that are going to be items that are in your cloud billing, in your cost, but may not necessarily be being consumed by Kubernetes workloads. And we're going to drill down into those a little bit in more detail. And then the rest of this down here is we do have a network. There's an optional network plugin that will let you then break down network costs, and we can annotate those network costs as being in cluster, cross-region, cross-zone, ingress, egress, so that way you can have a better idea of those network incurred costs as well. I'm going to come down into this. We're going to focus over the next 25-ish minutes or so. We're going to focus on the monitoring aspects. So Kubecost effectively has, you can think of it as being kind of three peers, if you will. The monitoring section, which we're going to spend the majority of the time on, and then this savings section, which then gives us some insight into where we can save save a little money on our workloads. And then there is a relatively new governance piece that we're going to touch on as well. But I'm going to start here with allocations. Allocations is your Kubernetes-centric view of the world. So when I'm looking at this screen here, these are going to be very much focused on Kubernetes objects. So what I'm looking at, what I'm broke down here by is, or what I'm aggregated by is namespaces. And we're looking at the cumulative cost for the last week aggregated per namespace. There are some interesting numbers here I'm going to point out before we move on. So the different dimensions of your costs that we're looking at, we're bringing in CPU, GPU, memory, storage, network, and the load balancer cost. So any of these places where you're incurring a cost, we'll be able to visualize. There are a couple of other numbers up here that are kind of interesting. This shared figure is going to represent a cost that you want to allocate to all of the tenants in your cluster. So for example, if you've got a piece of software that's a paid piece of software, an application that's used for maybe security monitoring or logging or something like that, and you want to share the cost of that application across all of the tenants in a given cluster, that's what this shared figure represents. This efficiency figure gives us the first sort of look at, maybe I want to go look at my workloads. They're not running as efficiently as they possibly could. This efficiency figure is the difference between resources requested and resources consumed in your Kubernetes cluster. And when we get down to the savings section, we're going to dig into this in great detail, but just kind of keep it in mind for now that this is an indicator that I can probably squeeze a little more work out of this cluster by tuning my workloads a little more appropriately. The other thing I'm going to point out here in this particular on this screen is this idle figure. And in my environment here, it's not much, but it's something. This idle figure, again, gives us an idea that we've got resources that are not being consumed. So this makes me think I could have potentially some over-provisioned resources in this environment. This idle figure represents places where the Kubernetes scheduler could go schedule workloads, but it's not. So it's literally just slack resources in the cluster that are not being consumed by any workloads. That's some of the information down here in the bottom. Let's talk about what we got up here. So Kubecost, this is the first thing we can look at is we can put a date range around my data. So if I want to look at anything from today all the way back to the last year, we can do that. We can put custom start and end dates here, but I can put a time boundary around the data that I want to look at. Once I've done that, I can move over here to this aggregation tab. We have a couple of different ways we can aggregate data. This is a simple namespace aggregation that we're looking at right here, but we can also aggregate by multiple dimensions using this multi-aggregation feature. So if I click on cluster here, now we are aggregating by both cluster and namespace. So I can see namespaces per cluster. So if I want to, visualize my data this way, I've got a number of different ways I can visualize it. I'm going to go back over to just a single aggregation here, but we can aggregate on any of these different types of dimensions. Another thing that's possible here is in the enterprise version, we can use SSO and RBAC to restrict a view. So if I want, for example, a particular team to only be able to visualize the data that's part of their team, I can use RBAC to limit that view to that team to only their resources. So this is where we're going to do aggregation. If you have a particular label, so if you've got a labeled workload and you want to be able to view that as an aggregation, we can put that label in here, and then that will also let us aggregate via that label. Once I've aggregated, once I've got my aggregation kind of looking how I want it, the next thing we can move on to is we can adjust the view a little bit. So this idle cost here that I talked about, we can leave it separate like it is now. We can also hide it so you don't see it at all. We can also share it by cluster or by node. So we've got a couple different ways we can then allocate those idle costs. We also have different ways we can visualize the data. So if I want to look at more of a proportional cost versus cost over time, we can look at it that way. I've got some different types of metrics I can look at here. We're looking at a cumulative cost. But if I want to look at a monthly or daily or hourly rate for a given metric, we can do that too. And then the next thing we can do, filters. Again, kind of like we saw in namespaces, I can filter this down if I want to add, say, a label for a product or a team or a service, for example. I can use that as a filter here. And again, we can just kind of more tightly drill down that view. And then earlier when I talked about that shared resource figure, so this is what's set up in my environment. So I am sharing the namespace. So a lot of, Kube system is kind of that core namespace in the cluster. Any tenant in the cluster is going to rely on services provided by Kube system. So in my environment, I want to share the cost for that namespace across all of my tenants. So this little section here allows me to share those different resources. So I've got a namespace that's shared. This $1,000 a month cost is going to represent, in my example, a security or a logging application. And we can also split out tenancy costs. What tenancy costs are, if you are running a managed type Kubernetes environment, so say, for example, AKS, EKS, GKE, something where that cloud provider is basically managing the control plane for you, I want to share the costs of that. So I can share this tenancy cost, and then that way the costs for all those cloud management costs also get shared amongst your tenants. All these things are configurable down here in the settings button. We can come down here and we can put in those numbers for shared tenancy, shared costs. All that stuff is configurable. One or two other things I want to point out while we're on this screen is I've got this inspect view. The right sizing and shared costs are going to come up here a little bit later when we get to another section, but I am going to touch on this inspect view right quick. What this does is this is kind of a drill down into that namespace. So now I'm looking at, I've got a chart up here. I can see some kind of data over time, and so I can see some trending information. This is my first sort of indicator that, okay, I might want to look at changing these workloads a little bit. My CPU is not particularly efficient. RAM's not great, but it could be better. And then down here, these green bars give me some insight into workloads that are running like a really low efficiency score. These are probably going to be the first ones that I want to look at when I start looking to make my workloads a little more efficient so I can, achieve a little bit of cost savings. Other stuff that we're going to find on this page is going to be some performance insight. So this is not necessarily cost related. It's more of a just, informational sort of panel. But we can see here, I do have a couple of workloads that are in danger of being out of memory evicted. And then I have a workload that's in danger of being CPU throttled. So again, not necessarily cost oriented, but gives you some insights about those particular workloads. I'm going to come back over here to this allocations tab. So the next thing I want to point out is how far down this can we go? So when I'm looking at this namespace, this is that Kubecost namespace across all of my clusters, across all of my environments that have a Kubecost namespace in them. If I drill down into this, now I'm looking at the controllers for that namespace. I still have the same sort of filtering and aggregation capabilities up here, but now I'm looking at it a little bit lower level. So with my controllers, I'm going to have things like my deployments, my daemon sets, things like that. If I drill down into this, now we are looking at, now we've drilled down into the pod level. So I can see the pods that are running this particular service. If I drill down into the pods, now I can see the actual containers that are running in this workload. Now I'm going to talk to this for just 1 second. And what we're looking at here is, this is how we're getting that very accurate costing. So I can see the resources that this workload is consuming. I can see how much of each type of resource is being consumed. This hourly rate is what we're pulling in from that cloud provider. This is just a public pricing API. But this adjustment then represents where we have ingested your bill and we've applied any savings plans and discounts to that bill. So that way we get an accurate cost for that workload. All of these we can open up in Grafana down here at the bottom. So if I want to open that up in Grafana and then go look at some, trending information, I want to do some, more long-term trending and analysis, we can open these things up in Grafana and we can do that. So that's allocations. Allocations, again, a very Kubernetes-centric look at the world. Assets then are going to be the things that are propping up those Kubernetes clusters. So this is going to be things like your nodes, your load balancers, your disk, your network segments. And again, same thing here. I can drill down into these. So maybe I want to see my nodes. We can see here, I've got, again, I'm in my environment, I've got multiple cloud providers here. So we're going to see AKS nodes, AWS nodes, or EC2 instances. So we've got a little bit of everything to look at. But as long as these are appropriately tagged, then they can be tied back to a Kubernetes concept. So for example, if a team or an application or a microservice is consuming these nodes specifically, as long as they're tagged with a given, appropriate for what it is, then we'll be able to roll this cost up for these external assets back up into that, into a Kubernetes concept. So you get a whole sort of a holistic sort of look at the costs that are associated for that given Kubernetes thing that's running, the microservice, applications, whatever it might be. So assets are going to be those resources that are used, that are directly involved in running the clusters. This cluster tab here, make this a little bit bigger. This cluster tab is going to show me clusters that are attached to Kubecost, clusters that Kubecost is monitoring. And we can see here, I've got details of these clusters. So this is going to give me what the cloud provider is, version of Kubernetes. Again, kind of just a broad overview, right? So how many nodes are running, how many namespaces. This is the total cost over the last week for this cluster. These estimated savings figures are based on the insight into the workloads that we can see for this cluster. This efficiency figure gives you a look at that cluster's efficiency overall as a whole versus broken down by smaller concepts. This panel right here is going to give us a look at, okay, we can kind of start to see again that my for this given cluster, my CPU is not efficiently allocated, whereas my RAM is actually in pretty good shape. The rest of this page is going to be just some trending information for the objects that live in that cluster. All right, so that's cluster details. Let's talk about cloud costs. Cloud costs then are going to be those things that we can see by virtue of the fact that we're ingesting your bill, but they may not all necessarily be involved in the running of Kubernetes. And the idea here is we've got, the product's called Kubecost, so Kubernetes is obviously a focus, but we had a lot of requests from customers along the lines of, hey, y'all are ingesting my bill. What else can you see in there? What other insights can you give me? Because you've got this data to work with. And so towards that, we've built this cloud cost tab, which is relatively new to Kubecost. And what we're looking at here is these are going to be things that we refer to as cloud costs or out of cluster cost. And we can see here that out of all these things that we're monitoring, and I've got a bunch of them, we can see that some of these are very actively used in Kubernetes, Kubernetes nodes or Kubernetes clusters. So for example, my EC2 instances, 94% of these are being consumed by Kubernetes clusters, whereas, say for example, my S3 storage is not. So this again gives me insight into my those extra costs that I'm incurring in that cloud that are not necessarily being used for Kubernetes, but I do want to be able to see them. I'm going to talk for just a second here about things that are coming. So if I drill down into this, I can see these AWS, I can see these S3 instances that are and what they're being used for. If I click on one of them, I can see some historical data in terms of the cost that this S3 instance is running over a week. But I don't have a way to break it down further into, say, for example, if I've got multiple parts of an organization that are leveraging the same S3 bucket to store maybe some common data sets. So within the next release or so of Kubecost, within the next probably 2 to maybe 3 months, we'll be able to drill down into these external cloud costs and then allocate costs here back up into a Kubernetes concept. So we're not quite there yet, but it's coming. So I like to look at this as being kind of a multi-stage sort of thing. So step one, visibility. So now I've got visibility into all my costs, my spend for these public cloud assets, broken down across everything from very Kubernetes-centric view of the world all the way to everything that's not necessarily Kubernetes. So first stop is visibility. I can see my things. Now what? The second thing that we want to look at here then is, now that I've got visibility into where my spend is going, how can I affect it? How can I make it better? How can I decrease some of that spend? And towards that, we've got the savings tab. The savings tab, and we're not going to go through all this in the interest of time, but we've got a number of different avenues that we can explore to achieve some savings in your cloud spend. I like to look at this as kind of bottom up sort of sizing exercise. So I'm going to start with this container request tab. If I click on that, now what I'm looking at here, these are going to be the controllers, the namespace and the associated controller. If I drill down into it, I can see that this particular workload, in the spec for this workload, I'm requesting 800 millicores of CPU, but we're only consuming 3. So the Kubecost recommendation is, let's set that to 10 millicores. This gives this workload enough overhead to do what it needs to do, but without reserving all this extra capacity that could be used for other workloads. And we're going to do the same thing here across RAM. So we're going to say, to make your workloads a little more efficient, let's look at changing your CPU request and your RAM request. The cool thing here is that these are configurable. So these recommendations that we're giving you back here can be customized based on a number of different avenues. So I can set a time frame around these. Maybe I just want to look at, if I have workloads that are, bursty over a short amount of time, I want to look at a shorter window. If I want to look at longer term trends, I can blow this out to a larger window. But if I grab a profile here, a development profile, we're going to start with these numbers that we're suggesting in the background, these recommendations are driven by 80% utilization of both CPU and RAM. So when we looked at that CPU example earlier, that recommendation is saying, if we set it to the Kubecost suggested figure, that's going to be based on 80% utilization CPU, 80% RAM. We can also change this. So if you think about the differences between your development and your production environments, development, I'm probably okay with running resources at 80% utilization. In my production environment, I very likely want to leave a little bit more overhead for those resources. So we can create profiles. So in my production profile, these recommendations back here in the back end are going to be representing 65% target utilization for both CPU and RAM. So the difference is I can create these different profiles based on different types of workloads, based on different types of environments, and I can get custom request sizing recommendations based on that given profile. The other thing we can do here is we can add filters. So if I want to filter this down to a particular, a service or a namespace, for example, I can add that filter here, and then those recommendations are going to reflect those things that I'm filtering on. So you can kind of follow that path up. There's a whole bunch of different ways we can right size this. Abandoned workloads is another one that I think is pretty cool. If we grab this little traffic threshold slider, and maybe we look at a week. So this is showing me workloads that have not seen so much as 1,000 bytes of traffic a second over the last week. And in Kubernetes world, if workloads aren't receiving any sort of network traffic, are they really doing anything? Chances are likely not. So this gives me insight into these workloads have been potentially abandoned. I can go clean these up, and then I can then go affect more savings. Once you've gone through all these activities, then the kind of logical endpoint to it, is I'm going to expand these. The logical endpoint then is cluster resizing. So if I'm going to go ahead and open this up as well. These are the information, these are the data sets that we're taking from this particular cluster over a particular time period. This is what we're seeing running. Based on this input, my current cluster configuration, I'm running this on 3 M5XLs to the tune of about $420 a month. We're going to typically offer 2 recommendations, a complex one and a simple one. In my environment here, the complex one and the simple one look very, very similar. Oftentimes, the complex one will have multiple different node types down here. In this example, it doesn't. But the idea is we can take if we look at my utilization figures for RAM and CPU, if I were to take this workload that's running on 3 M5XLs and run it instead on 5 T3A mediums, not only can I save a couple $300 a month, but I can get better resource utilization out of that cluster. The complex recommendation oftentimes will have even better utilization, but sometimes at the cost of a little bit more tricky to implement in terms of multiple node types. So this is kind of the end game with regard to savings, is I want to be able to resize my clusters, my nodes in their entirety, and then I can either more tightly bin pack those clusters, get a little bit more work out of them, or I can just scale them down and achieve some savings. I'm going to touch briefly on reporting because it's here and it's cool, but I also want to make sure we save a minute or two at the end for governance. Reporting, pretty straightforward. These are reports that are stored in this little reporting tab. To create a report, I have multiple different types. Allocation report, asset report, these are going to take you exactly where you think. So if I click on allocation report, it's going to take me back to this allocation tab. At this point, I can come over here and I can refine my view how I want it, aggregate by namespace and cluster. And when I've got this view how I want, now I save this report, I give it a name, and it shows up down in this reports tab. We do have a new type, an asset report's going to work the same. Cloud cost report's going to work the same. It's going to take you to those respective tabs in the UI, and then you can create a report based on the views there. One thing that's new, though, is this cost center report, which I think is also pretty cool. So if you think about cost center, they're going to be incurring cloud costs that may or may not be reflective of Kubernetes spend as well as Kubernetes workloads. So I've got a cost center name, and actually this is brand new. I actually don't have this set up in my environment quite yet. But what you would do here is you put in this cost center, a name for the cost center. You give this report a name. And then from here, we can add different things to this report. So for my cloud cost, maybe I want to say, let's look at the provider. So I want to look at maybe just AWS, or maybe I want to look at just Google Cloud. And then I have different metrics here that I can add to it. And like we've seen in a lot of these other areas, I can put some filters on here to make it, to kind of tighten it up a little bit. So I can add that cloud cost then to my Kubernetes workloads. And again, we see the same types of aggregations that we saw before, and we see the same type of filters that we can apply. So the idea here is I can take those cloud costs and the workload cost and kind of combine them, mash them all up into a combined cost center report. So this is new, 2 or 3 different types of report, but I think this cost center report, I think, is going to be pretty cool once it's all kind of set and done. Got just a couple of minutes left. I'm going to touch briefly on governance. Governance is relatively new to Kubecost. This is a new element that was added within the last release. This gives me a way. Governance is going to be, it's not fully built out yet. Governance is going to be kind of a 2 or 3 prong sort of thing, in that I can create a budget. When I create a budget, I give it a name. I give it a budget cap. Does it reset weekly or monthly? Do I want this budget to be based on a namespace or a cluster? And we'll just say namespace. Which one? We'll go with Acme Fitness. And then I want to take an action on this budget. So when this budget reaches a certain percentage, it can be below or at what that spend is set. Then I want to maybe send an email to a distribution group or send a Slack or a Teams webhook to notify folks that, hey, you're approaching your budget, you're at your budget, you've even gone over your budget. So configuring a budget is step 1. The next part of this is there's an audit piece that's being worked on. That audit piece will then allow you to go audit budgets. So you can see what has been deployed, what has been workloads that have been deployed or removed from a cluster, and you can see the effect on the spend for those workloads. So that's being built. The other part that's going to go with this is a tool that we call Kubecost Predict. Kubecost Predict is out in our GitHub repo right now. You can download it and take a look at it. But what it does is you can point Kubecost Predict at a manifest or a directory of manifests, and it will tell you what the cost to deploy that workload is going to be prior to it being deployed. And this is all based on having Kubecost installed in a cluster. And so we've already got an insight of the components that are running in that cluster, the associated costs. And then from there, we can take a look at that workload, and then we can tell you, here's what this workload is going to cost before you deploy it. That is also going to integrate with GitHub Actions. So the idea here is I can take that as part of my developer. You think about developer workload, CI/CD pipeline. I can insert that into my CI/CD pipeline as one of those GitHub Actions. Then I have visibility into what workloads are going to cost prior to them being deployed. So that's not quite all built yet, but it's coming soon. And that kind of covers my little tour of Kubecost. We've got just a few minutes left. I'll stop here. If y'all have any questions, I see we've got a couple here in the. Okay, so first question here, Dudley. So how current are these costs? So they typically to me this is a 2-pronged question. We typically say that we are going to be accurate to within about 5%, so accuracy, and then how current. So it depends on a couple of things. It depends on your bill provider or your cloud provider and how frequently they drop that bill. In some cases, it's about every 6 hours. In other cases, it's closer to 24 hours. And then what happens is Kubecost runs a component that's going to do that reconciliation. And between the data ingest and the reconciliation, that can take up to about 24 hours. So we typically say there is within 48 hours, data that's 48 hours and older should be 95% accurate. There is a way to turn on a visualization in the UI here to show you costs that have not yet been reconciled. And those are going to be more, we scrape Prometheus metrics every 60 seconds. So those are going to be more, accurate to within a minute or two, but with the understanding that they haven't been fully reconciled until all that reconciliation pipeline kicks off. That is all I've got for a demo. Goran, Morgan, I don't know if you guys have anything else you want to add.
Yeah, certainly want to thank everyone for attending, and certainly if there's any questions that you have, particularly for your particular use cases, we're more than happy to take those. So please feel free to reach out to myself, and yeah, more than happy to schedule deep dive sessions, particularly for your use case or any specific questions that you may have.
Yeah, perfect. And just shared sentiments. Thank you, everybody, for joining us today. Thank you, LimePoint, for your partnership. And anybody would like to learn more about our solution, please reach out to Goran, and his team would be happy to create a personalized demo for your use case. So again, thank you, everybody, for your time. Thank you, Mike, for the presentation, and Dee. And we look forward to chatting with everybody here soon.